Today we're going to discuss the types of statistics, research, variables, and scales of measurement that you'll need to know to be successful in the course and in conducting statistical tests. We can't measure the entire population. A parameter is an unknown value for an entire population. Therefore, it has to be estimated using a smaller sample representative of the entire population. For example, let's say we wanted to know the average IQ of people living in the United States. We can't select everyone in the U.S. And since we can't do that, we would select a sample or a number of samples from across the United States, test their IQ, and to get a mean or average. This unknown parameter, in other words the mean of every person's IQ living in the United States, doesn't vary. It is a concrete number. But every sample that we draw from this larger unknown population will have its own value of any statistics that is used to measure the parameter or estimate the parameter. Parameters are assigned Greek letters and statistics, or the sample, are assigned Roman letters. This is very important to remember. So you see here, a parameter is a numerical property of a population and a statistic is a numerical property of a sample. So for the sample we'll use, say, X bar for the mean, and you see the mu here represented for the larger unknown population. The same is going to be true for standard deviation and variance. Roman letters will represent the sample data and Greek letters will represent the population data. Statistics is defined as the collection, organization, and interpretation of data. A single statistic is a quantity that is calculated from a sample of data. Statistics is used to describe, summarize data, identify associations and relationships, and make predictions or generalizations. There are two branches of statistics. Descriptive, these are values that describe the characteristics of a sample or population, and inferential statistics, values that we can infer to the larger population from which the sample is drawn. The first few weeks of this course we will learn how to conduct some simple descriptive statistical tests. These are very important to help describe your sample, to make sure that it matches the larger population, to make sure that we meet assumptions of various inferential tests, and to look for, as I like to call it, boo-boos in our data set. Perhaps we've recorded some information incorrectly. If we conduct some descriptive statistics, we can screen our data for these errors and then clean the data. More about that later. Data is defined as factual information expressed by numbers or narrative. When we use numbers to represent data, those are numeric variables. When we use narrative or words to describe data, we call those string variables. Qualitative research utilizes string variables. These types of research investigations mainly use interviews of individuals and groups using open-ended questions regarding attitudes, feelings, and behaviors. Quantitative research utilizes data gathered in numeric form. These are collected from experiments, surveys, correlation, and meta-analysis. This is the type of research that we will limit ourselves to in this class. Variables. This is defined as a characteristic being measured that varies among individuals, events, or objects. A variable is an attribute that can describe a person, place, thing, or idea. The value of the variable can vary from one person or observation to another. Univariate data. When we conduct a study that looks at only one variable, we say that we're working with univariate data. Suppose, for example, that we conducted a survey to estimate the average weight of high school students. Since we're only working with one variable, weight, we would be working with univariate data. This data would be reported as mean, mode, frequency distribution. Bivariate data. When we conduct a study that examines the relationship between two variables, we're working with bivariate data. Suppose we conducted a study to see if there was a relationship between the height and weight of high school students. Since we're working with two variables, height and weight, we would be working with bivariate data. In univariate analysis, we're looking at the basic characteristics of one variable of interest: weight, blood pressure, glucose. We use this type of analysis to check the data sample to find extreme outliers, find errors, to examine the variability in a sample, to describe the sample for a single characteristic, or to verify the assumptions associated with an inferential statistical test. In bivariate analysis, where we look at more than one variable at a time, we can use more robust statistical methods such as the inferential test, ANOVA, and regression, t-test. Of course, we have to make sure that our data is normally distributed, that sample was collected randomly, and there's equal variability between the groups being compared. Variables are classified in a study as independent or dependent. With an independent variable, this is the one that the researcher can manipulate. It's also known as the effect, and some studies may have more than one independent variable. The dependent variable depends on the independent variable. It's the outcome that the researcher measures, and studies can have more than one dependent variable. An example: let's say that we want to know if different types of infant formula can affect growth velocity in babies. The type of formula doesn't change. It's the independent variable. It's the one that the researcher manipulates. Growth velocity is the outcome, and if our hypothesis is correct, it will depend on the type of formula. It's the dependent variable. Here's another. The type of NCLEX review guide on NCLEX scores of test takers. The type of guide or study resource would be the independent variable, and the score is the dependent variable. Quantitative variables can be further classified as discrete or continuous. If a variable can take on any value between its minimum value and maximum value, it's called a continuous variable. Otherwise, it's called a discrete or non-continuous variable. Here's some examples of non-continuous or discrete variables. Sometimes this is also referred to as categorical. The number of patients on different hospital floors. The number of languages that a person speaks. Number of people sleeping in a statistics class. Gender, race, blood types, diagnoses. All of these are categorical data. You can't average them together. You can't report a mean. You simply report the number and percent of each category. These are examples of continuous variables. Height of children, blood glucose levels, blood pressure, minutes required on a dialysis machine. All of these have an order to them, and they have measurable differences between the integers of each one. Quantitative variables or outcomes can also be assigned to a particular level of measurement. This is a very important slide. Each of the 4 levels of measurement has set characteristics. Lower level of measurement limits the statistical tests that can be used to interpret and display the data. So whenever possible, use the highest level of measurement. Moving up the measurement level allows for use of more robust statistical tools and greater precision in analyzing and interpreting your data. Whenever possible, Select variables that represent the highest level of measurement. And so here they are. Nominal level outcomes are categorical or non-continuous. There's no real relationship between these variables. When nominal outcome variables are used, non-parametric statistical tests such as chi-square and correlation and descriptive statistics are used to report the results. These statistical tests are very weak and limit the interpretation of results to the larger unknown population. Examples of nominal level data, also known as non-continuous, are gender, race, geographic location, religion, diagnosis, etc. Descriptive statistics are limited to number and percent, which is also referred to as mode. There is no mean, median, range, or standard deviation. Non-parametric tests like chi-square can be used to check for differences between groups. In our earlier presentation, we talked about the ketogenic diet example. A nominal outcome measure might be a single question. Did your child have less seizures while on the ketogenic diet? A yes-no answer won't tell us much, even if there are more yeses than nos, because we don't really know if they had a 2% reduction in seizures or a 92% reduction in seizures. All we know is that parents either said, yes, my child had less seizures, or no, my child did not have less seizures. So nominal level data don't really tell us a lot. The next level of measurement is ordinal. Ordinal data can be ranked in order and provide a relationship between the data points. However, there's no true zero, and we don't know the exact relationship between the ranks. This is always a dead giveaway that your data are ordinal. Examples are level of education, grade in school. We can use a few more statistics to describe the data. For example, we can use median, mode, percentile rank, correlation, and non-parametric tests sometimes. Most of the time, however, never can we talk about the mean or SD. We can only use the median, the mode, percentile rank, and some correlation. Let's look at our example before. The question was, while on the ketogenic diet, did the child have more or less seizures? We could improve our question from a yes-no to a Likert scale. We could say, strongly agree, agree, somewhat, do not agree, and have the parents check. Again, our conclusions are limited, but it's a little better than yes and no. This data is displayed using bar charts or pie charts. With interval level and ratio level, the distance between the data points has meaning. We can use the more robust parametric tests like t-test, ANOVA, MANOVA, regression, and types of correlation. Interpretation of results is more reliable. We select interval and ratio level variables whenever appropriate and possible. Interval and ratio level data are treated the same in most statistical tests. This data is represented as measures of central tendency like we use in descriptive statistics: mean, median, mode, range, standard deviation, and z-scores. Descriptive statistics use histograms, scatter plots, interquartile range to display the data. All statistics may be used for ratio level data, and most statistics can be used for interval level data. Again, if we go back to our example of the ketogenic diet and its effect on seizure activity in children, we can have a validated seizure activity tool that records all seizure activity during an established time frame. We have potential for true 0 to infinity for seizures that also might capture how long the seizure lasted, the intensity of the seizure, and the type of seizure activity. We can now use the more robust statistical tests to measure the effect of the diet. We can compare the mean number of seizures before and after the diet and determine the significance. If ketone production is measured, we might be able to conduct correlation and regression analysis to see if higher ketone production is associated with decreasing seizure activity. We might be able to show that even if number of seizures did not go down, the time or intensity of the seizures was reduced by the ketotic state. So as you can see, using higher level of measurement provides a lot more information and reliable interpretation than using lower levels such as nominal or ordinal. Properly selecting and identifying variables of interest in a study is crucial when selecting the appropriate statistic and entering the data into SPSS. Let's say you want to know the effect of a weight loss program on anthropometrics in elementary school children. The most practical field methods to measure anthropometrics include BMI, skin folds, and bioelectrical impedance as measured by a Tanita scale. You must first select all the variables that you'll measure so you'll know what data to collect before and after the weight loss program. It's important to collect descriptive data too. All this information should be entered into a code book. And pay attention to this because you'll conduct a code book in a later activity in this course. Taking the time to do this will help you think through the variables that you need for your study, what level of measurement they will be assigned so that you'll know how to go about collecting the data, and help you understand the type of statistics that you will need. Here's an example of a code book. Notice that this is based on our previous slide where we're thinking about looking at the effect of a type of intervention on weight loss in children. We're certainly going to want to collect the gender of the children, the grade in school, perhaps their race may have something to do with their weight, age of children, obviously weight, height, their BMI. We said we would collect skin folds because it's a measure of body fat. Tanita scale also measures body fat. So these are the variables of interest. Then we would assign the level of measurement as nominal. At least for this study we have only nominal and interval level. As we said before, we want to use the highest level of measurement whenever possible. Lower levels such as nominal and ordinal are categorical. Interval and ratio are continuous, and SPSS actually treats these as the same. The level of measurement dictates how we can report the data that we collect. For these nominal categories, we can report number and percent, also known as mode. And then we have to explain to SPSS what the numbers mean, how we're going to code the data. We can't simply enter male and female into SPSS. It won't recognize those terms. So we tell SPSS that we're going to code male as 1, female as 2. And these are arbitrary numbers. For grades, we're going to say every time we have a kindergartner, we'll type a 1. First grade will be 2, second grade 3, and so forth. We have to code for race. The continuous data does not have to be coded. We simply enter the number in because it is higher level, and we'll report that as measures of central tendency: mean, standard deviation, and range. Let's say that we've taken the time to prepare our code book, we've gone out into the community and collected our data. We will now use the code book to enter it into SPSS. This is a screenshot of what SPSS would look like after we've entered our data. Using the information from the code book, the variables have been identified, as you see here in arrow 1. Values assigned. Remember, SPSS thinks in terms of numbers, so we can't type male and female, we have to type in the number. And we've actually told SPSS that that's what we're doing here for this categorical data. And the third arrow shows where the level of measurement has been assigned or treated with each variable. Whether it's nominal, we have 1 ordinal here for BMI rank, and the rest of it is interval ratio level data, which SPSS treats as scale. Again, later on in this course, you will set up an SPSS file for yourself. This particular code book and data file was developed for the SPSS homework file, and you'll want to refer to this when you attempt the first assignment.